Hi, I'm Mike Bush.
I'm Paul New.
And I'm Colleen Sterling. Welcome to Ask the A&Ps from AOPA.
Now, this is the show where we try to solve your thorniest maintenance questions. So if you have a question, email it to podcasts@aopa.org for a chance to get on the show.
And make sure you follow or subscribe so you don't miss any of those thorns being thrown around.
And if you'd like to get on our email list, in North America, the easiest way to do that is to text the word SAVVY, S-A-V-V-Y, to 33777 on your smartphone. That's SAVVY to 33777. If you're not in North America, then the easiest way is to go to the savvyaviation.com website and click on the link at the top of the page to put yourself on our mailing list.
So I'm back in school, teaching at A&P school. Got a fresh crop of people that want to learn all about DC electrical theory.
Such an exciting topic.
It is. It's electrifying.
Oh.
And everybody they all seem to be having a good time. They really want to be there, and they're real excited about careers in aviation maintenance. I'm kind of wondering, I mean, there's two paths. They could go, jets and all the benefits and night shifts that you get at the airlines, or they could go the GA route where they jump into a shop like Paul's and, wrench on their own time and have a lot of fun and see a variety of different stuff. But I think more and more people are coming into this field because they're hearing that, there's a dire need for aviation.
Yeah, there's a big mechanic shortage. And we hope the airlines don't scoop them all up, because
they're working at it really hard.
Yeah,
they come in and they offer all these incentives to the students, like I'll pay for your tuition and relocation and benefits. And how do you combat that, Paul?
Well, that's a really good question. One way that we combat it is we try to grow our own. So we will hire someone local. The reality is, for general aviation, for small aircraft, because it's such old technology that it requires people, you're not plugging into a computer to tell you what's broken. Oh yeah, your oxygen sensor is bad, go change the oxygen sensor. We don't have that. It's much easier to take, I'm trying not to be negative towards somebody, but I can take a really good lawnmower mechanic and turn them into an A&P easier than taking a retired airline jet mechanic and try to make them an A&P on small airplanes. And it's not because one is smarter or whatever. It's just the airline, the corporate world, big airplane stuff, such a different mindset.
In the military too.
Yeah. And the military, the military, sometimes the military might be even a little bit worse.
Yep.
Well, the airlines is the worst because it's all non-replaceable units, and it's all if the box is bad, you swap it.
Availability is everything.
And military is similar to that as well. You're changing boxes, and in a group of 20,000 mechanics at big places, they don't have to have that many real mechanics, meaning out of 20,000, and I'm making up numbers here, so don't anybody quote me, but in 20,000 quote mechanics, 18,000 can be parts changers that are good at reading instructions, know how to use a torque wrench.
They do special jobs.
Swapping parts, and there's nothing wrong with that at all. There's 2,000 or less that are the ones that you can give them a problem and they can go solve it. They can go to the wiring diagrams, figure out the system instead of having to use a troubleshooting chart for the problem that the troubleshooting chart doesn't include. In general aviation, we rarely have troubleshooting charts. So if you're going to fix something, if the engine is missing a little bit on takeoff, but it's not showing up in the engine monitor, what causes that? Well, somebody has to know something about the combustion event. And most A&P schools don't teach a whole lot about the combustion event. You just you don't know what's going on. Anyway, so we grow our own when we can. But we got an email from a guy that's hasn't used his A&P in forever, and he wants to strike out on his own and start a shop. And I'm like, holy smokes. I grew up into it. So I didn't have this transition. It just wasn't the same. And as a Savvy account manager, starting back in when Savvy started back in 2008, I'd never worked at another GA shop. So I didn't know how other people functioned. Mm. And I'm telling you, it was an eye-opener. The first year or two as an account manager, the stuff I saw, like, holy smokes, don't do that. That's not the way to do that. Or I would often see, it's like, oh, I really like that. That's how that should work. That's how that interaction should happen. And it's been quite an education to see how various shops work. But yeah, to start a shop on your own, you hang out a shingle, and it won't take much to have all the business you can do. Mm. It's pretty amazing how easy it is. As long as you do good work, and treat people fairly. And by treat people fairly, that isn't sell it cheap. Don't sell it cheap.
You mean treat customers fairly?
Treat customers fairly, yes. Yeah. But that doesn't mean give them discount after discount. It means you're honest with them. You tell them up front what things are going to cost. You get everything done in writing. Normal business and procedures.
Stand by your work. Yeah.
Stand by your work.
Right.
Things happen in a shop. And a lot of times shop owners don't want to say this stuff out loud. But knowing a whole bunch of shop owners, there are some things that will be said quietly in the back room that won't be said on a podcast. Like, an airplane got delivered yesterday and there was a scratch in the paint. Yeah. And a scratch in the paint on certain airplanes can totally blow any profit you made on that one little job that you did. But you got to take care of it. And that's painful, but you have to take care of it. Yeah. And that's treating a customer fairly. Anyway, it's a thing, but it's cool. If you want to be a mechanic, not a parts changer, GA is way more interesting than the big worlds.
It's much more interesting. Working with hundreds and hundreds of shops the way we do. I mean, but I think the Savvy crew gets a view of the GA maintenance infrastructure that nobody else gets. Because we work with so many shops and we see the good and the bad and the ugly.
Yeah.
I don't know if you agree with me, Paul, on this, but my sense is that most GA mechanics in the field are pretty competent at swinging wrenches. The biggest deficiencies that I see, the number one deficiency is troubleshooting.
Yeah, it's difficult.
The people are constantly changing components that couldn't possibly have anything relationship to the squawk that the customer is complaining about, because they aren't thinking through the process properly. And the other thing I see is basically a fundamental fear of electrons.
Yeah.
It seems like GA mechanics are much weaker on electrical stuff than they are on anything else.
Yeah.
and Colleen, you must run into that constantly because that's what you teach. But I think it is worth mentioning because I do think, first of all, there's a huge demand for A&Ps, and second of all, I think more aircraft owners are going to have to start thinking about becoming A&Ps because there's just not enough capacity in shops to handle all of the requirements, the maintenance requirements that owners have now.
Yeah.
But I mean, there's two ways. There's two ways of getting an A&P. One is to go to a Part 147 school, like what Colleen. 147 is the right number, right?
Yeah. We get confused too.
Yeah, check me on that, guy. and which is you. What is that? Is that like a year and a half or something?
Full-time? Yeah.
Year and a half full time.
Yeah, I did part-time, so it took me 3 years or 3.5
And the
years.
other way is to basically do it through experience, through wrench swinging, or apprenticeship or something like Paul. You're a lawnmower mechanic, and Paul hires you, and 30 months later you can go
take the A&P. That's right.
Take your A&P test. And I did it that way, but I didn't have the good fortune to be able to go to work for Paul, and I did it on a part-time basis over like a 10-year period, and the 30 months experience works out to be 4,800 hours of experience that you have
That's
to
a bunch.
document.
Our next question is from Greg, who is unfortunately caught up in the Vans RV mess. So go ahead, Greg, what's up?
Well, as I'm sure you all know, there's a lot of information out there regarding, do you trust the engineering reports? Do you not trust the engineering reports? And Section 5 of the instructions goes on about cracks are bad, no cracks, you never want cracks. Mm-hmm. I personally believe that Vans is too much on the line to not get this right, and I'm inclined to trust their engineering work and what they're representing. But at the same time, obviously, they have a very vested interest in making sure that they can continue to sell product and remain a viable company going forward. Given all the new information, I've seen the Kit Planes video that they did trying to calm everybody down. But I was honestly wondering what your take is. My empennage kit only has 12 parts affected. They're not installed yet, so those are easy enough to deal with. But I do have a quick build wing kit that's coming at some point in time, and that could be riddled with them. And I know some of the parts are not replaceable. They're going to come up with engineering workarounds to reinforce them. But I was just wondering, what is your take on cracks in aluminum parts and just the testing that you've seen in general? And I'm inclined to be confident in what I'm building. And you guys are certainly experts on almost everything airplane. So thought I'd ask.
Let me just make sure. Many years ago, I was building an RV-10, which unfortunately the building that it was in burned to the ground, and there went my kit. But just so that the listeners are aware and make sure that I'm correctly aware, these are the small cracks that occur during the dimpling of the skins. Is that correct? So you have a hole that is punched or drilled, and then you flare, or you have to bend the metal, which in effect enlarges the hole. Yeah. And that's where you get the stretching or the cracking occurrence, right inside the hole.
Yeah, and they're calling them manufactured cracks versus fatigue cracks.
They are, because these parts haven't been in service. Right. So they're not fatigue, and this occurred on a single event during the manufacturing process. I would argue, and I'm not going to argue, but I would say that when sheet metal work is done on certified airplanes out in the field, we use the dimpling tools with the rivet gun and the set, and you hammer it together. I would venture a guess that a lot of those have these little cracks. This is probably not uncommon, but nobody's looking. Now, I don't know about the specific cracks that Vans is having trouble with, because it's a different process. But for these, whether you squeeze or use a gun to hammer it out, there are rough edges on that inside of that hole almost every time. And at what point it becomes a crack, I'm not sure. But Colleen, what did you find out?
So I thought when he said the Vans mess, I thought you meant the restructuring of the company. I had no idea that there was an issue with how they were manufacturing parts, introducing cracks. So that's completely new to me. I mean, my first inclination was if you have a kit that has cracked parts, I'm not going to install that in my airplane. But you're
Yeah.
not talking a big crack. You're talking, this is a known issue, microscopic or very small cracks in the holes
Yeah.
when they dimple the holes. Have those cracks, have there been examples in the field where those cracks have propagated and caused real issues and parts had to be removed and replaced or reinforced?
I don't know if there's any airplanes with the laser cut parts actually flying yet. They might be, but I'm not sure. Most of the testing that was done has all been in Vans's testing lab, and I know they hired a third party to do a lot of engineering work to examine the issue. And in their tests, they found that fatigue cracking occurred before the manufactured crack got larger, and the fatigue cracking never actually made its way to the manufactured crack. There were separate cracks in their testing. They never connected or became one. And no, they never showed any evidence of the manufactured cracks getting worse over prolonged use.
So how long are these cracks? Are we talking a thousandths or two?
I believe so. I didn't look at the actual measurements, but they're small. I know you can see them with the naked eye. You don't necessarily need magnification to see them.
So if you came up with a tool, a sanding tool, you might even call it deburring, to smooth that edge, I think that would be, as long as you didn't cut too much material. That's what I do. If we dimple one, we inspect it. Now, it's visual inspection. We're not getting out a ×10 magnifying glass or something like that. But we take a look to make sure that when we flare, it doesn't split or something. And you always end up with rough edges. So sometimes we'll just take a piece of sandpaper on the end of our thumb and just spin it on that expanded edge, which is the one that bows out, the convex end of it. And we end up with a smooth surface. Well, if you've got a smooth surface, you've eliminated any stress risers like you would dressing a propeller leading edge or something. And we never thought anything else of it. And that's pretty common in the sheet metal world. So, but the laser thing is a new element, and that's the issue.
And it's where the laser, I believe it's when the laser starts. The company that was doing it, they were starting it right on the diameter of the hole versus in the middle. And that point leaves a burr that's impossible to get rid of unless you upsize the hole.
Wow.
Ooh,
and if you have a spar, whether it's your rudder spar, horizontal stabilizer, wing spar, whatever, that's a lot of holes. It's not a one-off upsize here or there.
I just have a funny feeling that I don't think wings are going to start coming off.
I don't think they are either.
It is really, because you're building an airplane from scratch, and everybody that builds an airplane from scratch, that first time you take it out, in your mind, you're thinking, everything is perfect. I did a beautiful job. I reset that one rivet over there 6 times so I could get the proportions correctly on the rivet tail. All the things that manufacturers at Cessna and Piper and those places, it's like, you know what? It's not worth the time to get that rivet perfect. It's good. Move on. And to taxi out with known imperfections would just drive me nuts. I would have a really hard time with that.
Yeah, putting all that time into a build.
Yeah.
Starting with something that could potentially, down the road.
Well, what's your option?
Yeah, I don't think he has an option.
Are there any options yet?
My tail kit, that's easy. I'm just going to replace the 12 parts. Half of them are replaced for free because they're labeled as red must replace. The other 6 are they're in the okay zone, but there's only 6 of them, and they're the bulkhead the bulkheads in my tail cone. So I'm just going to go ahead and replace them. It's like $150. It's worth
And you can
worth
get
the
some
money.
that are done correctly. They have
Yeah.
those available.
They're
Okay.
well. Eventually, I don't know when I'll get them, but I will get them at some point in time. My wing kit is more concerning. I have no idea if the wing kit I'm going to get has laser cut parts in it or not. I know that the ones that they have right now in inventory, people are getting them as is, where is, with replacement parts and engineering workarounds for major parts that they don't want to have people drill out and replace. Because I know some of them are spars, and some of these larger spars, I know they don't want you to drill them out and replace them. And I think they're coming up with whether it's doublers or other things to try to work those. I mean, that is what it is, unfortunately, at the end of the day, unless I want to fork out the money for another wing kit. And that's essentially the only other option.
Probably just dribbling a little JB Weld in there before they pull the rivet, right?
I don't know. I'll bet you in all of these podcasts, we have mentioned JB Weld in at least 50%.
Or duct tape.
Or duct tape.
Yeah. I'd say that's accurate. I've listened to every single one of them. Sometimes more than once.
But you haven't taken delivery of the wing kit yet, right?
No, I haven't.
So can't you say I want to hold out for the new laser cut parts where they corrected the software that drove the laser?
That you do not get that option. You either agree to so in the chapter 11, Vans has what they've done is they've canceled all the contracts as executory contracts as allowed in the bankruptcy code, unless you agree to modified terms. And you either accept the modified terms or you don't. And when they're ready to send you your kit, you either take it or you don't, and you're just out of the game. So unfortunately, that game isn't being allowed. You're not allowed to play that card and just wait. I do hope that maybe I'm far enough along in the wing kits that the laser cut ones are exhausted before I get mine. Originally, I was slotted to get it in Q4 of 2023. Before everything's really started happening. I haven't gotten an update since, but I know they had, I think it was 10 kits in inventory when they filed bankruptcy. But I have no idea where I am in the line as far as, there's one of those mine or not. So I'm just waiting, waiting in silence.
I got to believe that they're going to be very, very cautious from an engineering standpoint and wouldn't ship a kit that they thought had any likelihood of coming apart.
As I said, I think it'll be safe. It'll just be frustrating.
Yeah.
Disappointing might be a better way.
Yeah. It is what it is. When you have massive growth and you're a small business, that can be a very difficult thing.
These cracks are only where holes are dimpled, so it's only where there's flush rivets.
Yeah, yes, I do believe that the parts that don't have dimples, unless it's a primary structural component, they are being listed as safe to use.
So it's all
so where the wing skins attached to the main spar, those are flush rivets, not
Yep. All solid flush rivets. There's not too many pop rivets on the 10.
This is good. We like solid rivets.
It's been fun to build. It's taken me longer than I'd like to admit, but I enjoy the process. I bet.
You're the only person that's ever said that.
Yeah, you're the only one that's taken this long to build a 10.
I finally got over my deburring fears. I just worried about, I've been scared to death of messing up the deburring and causing cracks, and then all this happens, and it just sends your mind spinning a little bit.
My recommendation on deburring is do it less.
That's great. I probably started doing it too much then.
Valves where you don't do enough.
Most people they'll deburr from both sides, and you end up with knife edge. And so you're actually creating a knife that wants to cut the rivet, when really what you want is a nice straight edge in the hole.
Uh-huh.
And you just want clean, sharp corners.
Right.
And what you end up with is people get in there with their little deburring tool and they deburr the living life out of it. And you just cause more trouble. So
I feel like I should just run some Scotch-Brite on the outside of the edge just to knock off that top.
If you could, you don't want the Scotch-Brite because you don't want to mess up the alclad layer.
Alclad,
Yeah.
But just at each hole, just barely touch it. You're deburring. You're not shaping. You just want to get rid of any residual edge or sharp point or something. Just barely touch it. Just a little bit. That's all you got. You're done.
Okay. Good deal.
Yep.
I'm going to remember that tonight when I'm in the garage.
Okay.
He'll practice it a lot.
So the dimpling is done at the factory on these kits as opposed to you doing them?
No, we do it. I do it.
You do it. Okay. So you're creating the cracks.
Yep.
How convenient. Wow.
We almost made it through without blaming Greg for the problem.
That's all right. My wife would say that's right in line with the norm. It's my fault.
Okay.
Oh,
All right. Well, Greg, sorry that you're in this predicament.
yeah, sorry,
But,
that's tough. But
You'll make it out someday.
I appreciate it.
When you actually finish the project.
That
you'll
was
look
a
back and
huge,
say, this is good.
a huge shock because we all just assumed, Vans was basically taking over the experimental world. They had to be making money hand over fist, and then to hear that they were in bankruptcy, that was really a shock.
Yep.
yeah,
It was.
it'll come out of that.
Unfortunately, the laser cut part issue, and then they had a couple quick build kits with bad primer that had corrosion issues.
Oh,
and then just the massive growth. But I think the laser cut part, the loss from that really tipped him over the edge.
I didn't realize that. Wow.
I think it cost him over $5 million so far. So
Yeah.
Ooh, that hurts.
if I remember correctly from the bankruptcy filings. So.
Wow.
Interesting. Well, I hope they come out of that.
Yeah,
We need them.
we do.
Yeah, no, we do
They're
need
good.
that.
Yeah. Yeah.
I like them a lot because I understand sheet metal, and I can go look at one and say, "Yeah, that one's going to hold together."
It's not
Those
plastic.
composites,
know,
somebody mixed
plastic
it wrong
airplanes.
or something. And,
Yeah.
oh well. Anyway,
Okay.
thanks for the call, Greg. That was really
Yeah,
good.
Good luck, Greg. Hope
Yeah.
it
Hey,
works
thanks for
out.
your time and thanks for having me. I appreciate it.
All right.
Our next question is from Travis, who has a vexing gear problem. Go ahead, Travis.
Oh, thanks, guys. It's really good to talk to you. So I've been listening to the podcast for a while because I'm a ferry pilot. So thankfully, you guys have helped me with a lot of dubious mechanical airplanes. So
We're good. We're good at dubious.
yeah,
We're dubious.
yeah. As a ferry pilot, you deal with that a lot. So, but this time I was tasked with ferrying a Wheeler Express 2000 RG, which is an experimental airplane, supposedly the only one of its kind. And it really showed because there was no checklist, there's no maintenance manuals, there's no really anything for it. That when I received it, normally I just fly the airplane, but this one had been sitting for a while in an airplane or a hangar close to me. So the guy tasked me with finding an A&P and getting it up and running. It had been sitting for about 6 years. So we did a really extensive annual. We went through the whole thing. With it being experimental and with no maintenance manuals, we just kind of went off of everything that we could think of and do. Obviously, part of that would be jacking it up and retracting the gear, test to make sure that worked and everything was looking good. And on the jacks, it worked perfectly. There was no issues. We tested the emergency system. That worked too. And also for context, we figured out through troubleshooting that the system is hydraulic. So it's electrically, has electric switch, but it's hydraulically actuated. And it's got one singular pump in the back behind the car compartment. And then it's got a couple pressure switches and one pressure gauge and a little light that says whether the pump is on or not. And it uses pressure to pump the gear up and hold it up. And then it uses pressure to pump the gear down. And if it loses pressure for whatever reason, it'll just free fall. So that's basically how the system works. Seems like a pretty simple system. But we, on the ground, jacked it up, works no problem. Did a bunch of other stuff to it. That's not really relevant. Basically, after the annual's done, went to take it up for a post-maintenance test flight. Again, no gear retraction speeds, no know anything with when to retract the gear. So I kind of was just off the cuff, working with it. So first flight, I retract the gear at 100 knots indicated, because that felt pretty good. And it worked pretty well, came up and down, no problem. Second flight that I tested with it, did the same thing, 100 knots, retracted the gear. And as the gear retracted, you had the little light saying that the pump was on, and you could see the pressure build up. But it's got 3 lights in the dash that just have blank for up and locked, green for down and locked, and red for in transit. And when I retracted the gear, the left main red light stayed on. And I thought it was probably just a micro switch issue. So I elected to just continue with the flight for a little bit, and noticed that there was a bit of a speed penalty with it. So I turned back around, got into the pattern, put the landing gear switch down. Landing gear came down, no problem. Everything was good. Landed, put the gear back, airplane back up on jacks, swung the gear, didn't change anything, and came up and down, no problem. So we thought that was weird. Checked a bunch of stuff, checked the hydraulic level, checked a lot of other things, and checked the micro switches, and nothing. So I elected to take it back up, did some more testing with it. This time I thought maybe let's try a little bit higher deck angle. So I tried 80 knots, which is actually pretty steep in that thing. You're hauling the nose up pretty high. And so I tried retracting 80 knots, and it worked. No problem. The 80 knots, the gear would come up, no problem. And did a couple more test flights like that, but eventually got to the point where one of the flights I retracted 80 knots, and the red light on the left main stayed on once again. So that's kind of weird. Went back on jacks, swung it again. It was fine. So this kind of went on for a couple flights until eventually one of the flights tried at 80 knots, and the gear had the same red light on retraction, so that it was still in transit. And when I went to go extend it, I put the gear switch down, and nothing happened. So the gear didn't move, the pump didn't turn on, none of the red lights turned on, the red light didn't go out, just nothing. You couldn't feel the gear at all. So I thought that's kind of weird. So I checked all the things that I normally would check. Checked the circuit breaker for the pump. That was not in. That was in. It was not popped. Everything was fine. So I tried. Maybe it was the switch. It was a little loose. So I tried flipping the switch a bunch to try to get it to electrically actuate. That didn't do anything. So I just reverted to the only thing that I had left, which was the emergency extension, which was a little nerve-wracking for me because I've had to gear up an airplane this year before because the gear wouldn't extend. So that was a little nerve-wracking. But there's a little valve that basically just releases the pressure. And with the gear switch in the down position, the moment I released that valve, the pump kicked on and powered the gear down, and everything extended without an issue. Went back and landed, put it back up on jacks, didn't change a dang thing, and it worked flawlessly.
Of course it did.
So I said, you know what? I know what Colleen, Mike, and Paul would do in this situation. They'd mount a camera to see what's going on.
You need to borrow someone's camera.
Yeah.
Oh, well, I use my own. I've done it before. I'm used to mounting cameras on stuff. So I mounted the camera on the step, aimed it directly at the gear, and did another flight, and noticed that on initial retraction, even at 80 knots, the left gear would stop, basically parallel to the wing, acted as like a speed brake. And then when I went to go put the gear down again, it didn't want to come down. Same thing, nothing moved. And I noticed that there was less pressure than it normally would have when it's all the way up. So I did the same thing, did the emergency gear extension. It came down. I've dubbed it now the alternate gear extension because it's not really an emergency. It's just an alternate method nowadays. Yep. So just release the pressure, gear came down, and then I put in a bunch of flaps and tried to haul the nose up to like 70 knots, which is very slow, and pull it up that way. And I reviewed the footage afterward, and the next retraction, it still was in transit, stuck in transit, but it went a little bit further. And then I, cycled it again, and the next time it came up. And then after that, next 2 cycles, it came up no problem. And it seems that sometimes it comes up, sometimes it doesn't. But the main variable that I can find is airspeed. And I'm not entirely sure why, because on the ground it works perfectly. And I called the people that actually designed the system, and they just said, well, it does that. She just does that when she sits. So why would landing gear do that? I'm purely baffled, and everybody I talked to is purely baffled as to why
So
a system would do that.
You note in your write-up that it's based on a Glasair 3 type landing gear configuration. We have
Yes, that's what I was told.
all the time at Reno with Glasair 3s. They try to go racing and one of their gear is hanging out, and they can't race very fast with one wheel out. And the guy who keeps winning at Reno, Jeff Lavelle, he's developed this technique where he takes off and he does this big high deck angle, to get the gear up, and then he levels off again. Robbie Grove raced a Glasair 3, Robbie Grove of Grove Brakes and Wheels, and he completely redesigned the system on their Glasair 3 to get rid of that mess because they didn't want to deal with that. So it's a classic problem with Glasair 3s. That said, I can't tell you why it happens, but you're not alone. Just like your
Travis, did you say that the system has a hydraulic pressure gauge?
It does. It has a singular pressure gauge that reads 1800 or so when the gear is completely up and locked. Locked is a relative term. And then it's got.
And when you have this problem with the left gear hanging down a little bit, is the pressure gauge at 1800 or is it less than that?
It typically was a little less than that. Yeah, about 15 or 16 or so.
So what tells the pump to stop? So I'm associating this with certified landing gear systems, which never have these kind of problems unless something's broken.
Well, there's
so
presumably a pressure switch. It cuts
right.
it off when it gets to 1800, right?
Yeah, but if it doesn't, so if he's at 1500, is the pump stops at 1500? Is that what you're saying?
Yeah, it seems like it. Now, I did notice. I mean, there's a bunch of different flights and a bunch of different things happen. I'm always the only pilot in there, so it's hard to keep track of everything at once. It did seem like when it was stuck in transit, or sometimes even when it worked, when the right gear came up, it would momentarily spike. And I had a theory that as the right gear came up, it would spike the pressure to 1800 and shut off the pump.
Yeah,
and then it would right back on.
Yeah, which sometimes I think it does, but I think the low side of the pressure switch might not have.
Valve
but the switch probably has some kind of hysteresis band where, if it gets to 1800 and cuts off, it's going to have to get to something significantly less than 1800.
Significantly less, yeah.
Does this pressure switch have an adjustment screw on it by any chance?
I think they have an adjustment.
I wonder if you could try to crank the pressure up to 2000 psi and see what happens.
Blow your out,
blow out some hydraulic lines.
You're not going to blow anything out at 2000 psi.
Well, in the avionics world, the way you fix things is you just keep turning up the applied voltage until something smokes, and that's what you change.
And then you back it down.
You back it down a little bit.
I didn't know you could adjust them. That's an interesting thing.
So the other theory that was kind of tossed around was that there was excess pressure built up in the downside, which I can't really make sense of that. But they were going off of that because of other issues with, I guess, other Glasairs that had that issue. And then the fact that it wouldn't come down sometimes when you push selected the gear switch down.
Switch does. The dump switch is there to relieve pressure when the hydraulic fluid gets warm. And we have that in the Legacy too.
But there's presumably a hydraulic shuttle valve, right? That
switches the pump reversible.
That switches the power pack pressure from the upside of the actuators to the downside of the actuators.
Yeah, that would be
right, because the normal way of extending the gear is hydraulically. It's not free fall. Free fall is the emergency.
Yes, that's correct. Free fall actually just releases the pressure, and then it releases pressure, and then
like on a Piper, on an Arrow or a Seneca.
Mm-hmm.
Yeah, without really understanding the design of the system, I mean, I can relate it to the 1979 and newer Cessna single-engine retractable systems are like the most bulletproof there are out there. There are no uplocks. It all works on pressure. The pump doesn't know which way the gear is going. That's all done with the handle. The pump just knows it's above 1100 PSI or it's below 15 or it's hit 1500 PSI. So the pump comes on if it gets below 1100 and it switches off when it hits 1500. And if it ever drops below 1500, and Mike talked about hysteresis in the switch, it doesn't take but just a few pounds. Yeah, it's just a blip. But 1500, it drops down to say 1450. Man, the pump comes right back on.
Okay.
And in a 4-hour flight, the pump should never come back on.
Yeah, or you have bypass going somewhere.
But we don't have a valve. We don't have to release the pressure in the sense that you are. And we never have. The system is just, it's just dirt simple. It just doesn't have to have, I don't know. Your system should work. And we had some Lancers. We had a Lancer in particular attack one of our mechanics one time in our shop when the nose gear collapsed.
Ooh.
And we since don't work on any experimentals. And so one of our guys got trapped underneath the airplane and it's in the shop. And so we called the people that usually worked on the airplane. They said, "Oh yeah, we didn't send you the little device you're supposed to clamp on the drag link so the nose gear doesn't collapse." I'm, what are you talking about? Who designs a system that can do that?
There's a piston that forces it over center and locks it so that it can't unlock.
Right.
That can get weak. Is that
well? And the spring door, spring literally from a spring door, a screen door. Is what holds
like that.
the
It's
drag
piston.
links over center.
Yeah, and it has certain pressure. And
so, yeah, we said, you can come get your airplane. We extended the nose gear. Bob got stitches. It was
wow,
pretty scary. Rolled it out and said, "I'm not touching that ever again."
Oh, it was Bob, huh?
Yeah, it was Bob. Yeah. And so that tells you how long ago it was. But I was just in shock at a system that could be designed like that. And come to find out, the Evolution, who a friend of mine built, and I flew around with him quite a bit, has a very similar design. And every time he landed, he had to open the valve. So as Colleen was saying, that the pressure couldn't build up on the gear upside and possibly release the down locks while the airplane just sat there.
I've never heard of that. That's interesting.
Yeah. So, but apparently they've redesigned them. But in flight, all the vibrations and stuff, you got a lot of O-rings. The system's been sitting for a while. O-rings like to get hard and they shrink. So I have a sneaking suspicion if we don't have a switch issue, which I think is a good possibility, that you also have an O-ring issue. Just out of curiosity,
you mean like
Colleen,
a bypassing actuator?
Bypassing actuator, yeah. So that one, your left gear is always the last one to come up. On the Glass Airs, is it typically the same gear? Is it typically the left one that's slow coming up?
I think so. Yeah, there's a sequence. The right
Yeah.
one comes up first, then the left. Same with the Lancer, I think.
Is that due to prop wash?
I don't know why they pick one over the other. That might make sense.
I have a feeling somehow prop wash is part of this issue.
So they want the one that's more subject to prop wash to come up first because the
Well,
pressure is fresh.
I have a question. You ferried this airplane some distance?
Yes, actually, I have it delivered to the new owner in Las Vegas, so it came from Oklahoma.
The question is on a long flight in this airplane, did the pump cycle at all during the flight, or
no? Ironically, the pressures kept building. It got to about 2,800 psi before. Yeah, before the pump
running.
No, the pump was not running. That's the interesting thing. It has a light that says whether the pump is running or not.
Yeah.
It never kicked on, and the pressure just kept going and going and going. I was afraid of blowing lines, so I selected the gear. I slowed down and cycled the gear in again. Bled some of that pressure off. I absolutely baffled me how it was building pressure, but
if it were my airplane, I would invest zero effort in fixing this problem. And I would spend all of my effort in replacing this system. This is absurd.
That's scary.
There's no way that should happen.
Could you have just cracked the dump valve to bleed off some of that pressure?
Yeah, that's essentially what I did. Yeah. The first time I slowed all the way down and cycled it all the way just to be safe. But then the second time, I'm like, you know what? I think I could just crack that
That's
and dump
crazy.
valve and cycle it.
So what's
And
making
pressure.
I mean, it's building pressure because it's getting hot, right? The fluid is getting hot.
Would it be air? If there's air in the system and expanding, but that wouldn't, I don't think that could bring it up that much.
Not that much.
Just because of the altitude that he's climbed to.
Usually for Lancers, it's too hot, so you can't bring the gear up at all. So cracking the dump valve is the way to kind of just relieve that pressure on the upside so that it'll come up. But the dump valve is there because, well, that pressure issue is because the hydraulic fluid gets warm, but it just kept getting warmer and warmer, and it's no,
Well, we don't know that it got warmer. We know the pressure came up.
that's true. Oh, we don't.
Maybe we can modify this airplane to use a Mooney Johnson bar gear retractor.
I used to have a Mooney, and that would have been absolutely delightful. Oh, you have no idea. It's just because it's not my airplane. I'll gear up my airplane, that's fine, but not somebody else's airplane. So
it's hard to troubleshoot experimentals because you don't have a maintenance manual really. You don't know what the builder did. The builder probably modified it off of the original design. Who knows?
But it's almost sounding like this system is like got a known deficiency. Not just this airplane, but the whole design of the system.
Overly complex, and it gives a lot of people headaches. But the good news is there's only very few of these Wheeler Expresses with this system. So this guy is really on his own. He's a test pilot.
Go yank the system. Go yank the system, the hydraulic part of the system, out of a 1980 or 1982 Cessna 210 or 182, an R182.
Cardinal RG.
Or a Cardinal RG. Don't use the
182.
switches in the Cardinal, but you can use the pump.
Yeah.
And I'm telling you that it'll work. It will do great.
Yeah, but there's so much plumbing they'd have to change, and there'd be a lot of work.
Or then don't go through the work and land gear up someday, and that will solve the problem as well.
That will solve the problem. Or weld the gear down. That'll solve the problem.
Or weld the gear down. Even
weld the gear down. Yeah, that's one way to do it.
You guys are getting mean now.
Well, it works. It works. I figured out how to get it delivered to Las Vegas, and that was the end of my part.
You did your part of the contract.
I did write him an entire manual on quotation marks.
The manual says shortly after departure, do a split S while you're retracting the gear.
It was something like that. Yeah, basically
use the dump valve to landing.
Yep.
Makes sense to me.
You're a brave man, Travis. I don't think you're flying airplanes like that or fixing them. Were you flipping this airplane or were you hiring?
No. Actually, the guy had bought it sight unseen, and I happened to be in the area, and he just figured that I could find somebody to help work on it and get it fixed up and flying. But originally, I was supposed to just fly it over there, but then we had to do a lot of work to it.
He doesn't listen to the podcast, does he?
He might after this. I don't know. I'll tell him.
No. I think you probably want to tell him this is a podcast you don't want to listen to.
I don't think Travis is a ferry pilot. I think he's a test pilot.
I think so. In this case,
on that case, definitely, yeah.
Well, great question, and you're very brave for bringing an experimental on the show because we usually deal with certified stuff. So
you're brave.
Yeah, but thank you. It's very interesting, and your troubleshooting. I really admire all your troubleshooting techniques because you didn't just give up. You actually pulled out all the stops.
Well, he didn't have any choice.
Yeah, he wanted to safely fly it, right? Yeah.
He was highly motivated.
I hope you got extra pay, hazardous duty pay for this flight.
Yeah.
No. Actually, I don't charge nearly enough, but that's okay with me. I like this stuff.
Yeah. Good for you. Well, thanks for being on the show.
Yeah. All right. Thank you very much for having me.
Okay.
Have
a good day.
Fly
Good
safe.
to see you. Our next question is from Brian, who is perplexed by plugs. Go ahead, Brian.
Hi, all. Thanks so much for having me on the show. I really appreciate everything you guys do for general aviation. Long-time listener, first-time caller. So I own a 1994 Bonanza A36 with an IO5 50B.
Wow.
Great airplane, love it. I've had it since about 2016 now.
Mm-hmm.
And this last annual I had, I think it was back in September, about September wrapped up. The shop came to me and said, it's time for new spark plugs. You need 12 new spark plugs. They've all gone bad, apparently. So, okay. So I said, we'll do that. And I had iridium fine wire plugs on the engine. came that way when I bought it. They had about 800-ish hours on them, a little over 800 hours.
Wait. I hate to interrupt you, but what was bad about fine wire plugs at 800 hours? What
Not
was
much
they
bad?
going on
normally
iridium
go
plugs.
well past TBO.
Yeah, 2,000 hours plus.
Did they drop them?
Yeah.
Yeah.
So I can neither confirm nor deny that somebody may have stuck them in the bead blaster or something
Oh,
like that. Or,
yes.
because the next part of my question will kind of lead you to why I thought this. So because I was a little suspicious, and we went back and forth on whether I really needed them or not. But I said, okay, fine, we'll do this. And they said, we really recommend massives. Let's put massives in there. And I was like,
oh,
okay, why? And so we had this back and forth of how they think they perform better, or how they think they've had better luck with them. And I had Champion fine wires, and they insisted on Tempest massives, and we went back and forth for a while. And finally I conceded and put those in and had those put in, and just to see if there was actually any difference. And so that's kind of the root of the question, other than the fact that we all know that iridium fine wires cost a lot more than the massive. They're more expensive, and they are supposed to last longer. Performance and operationally, is there really any difference? And does one work better if you fly lean a peak in a big bore versus a small bore? Is there certain types of operations one like over the other? And then is there really a difference between a Champion and a Tempest when it comes to fine wires and massives?
Well, so I'll make a couple of comments. We've got a lot of information on this, a lot of history, but a fine wire will typically idle better, a little bit smoother. It doesn't make any difference operationally, but it does. It'll idle a little bit smoother than massives. I wouldn't be too upset about having gotten rid of the Champion fine wires, especially if they were the older style that were not pressed. The innards are pressed together on the Tempest. So you don't have corrosion issues, you don't have problems with high resistance and that sort of thing. On the older Champions, that was a big problem. And they've changed their manufacturing process. I have not installed any of the newer styles, so I can't comment on whether they're doing better. The ceramics are still fairly small on the Champion fine wires versus the Tempest fine wires. The ceramic insert on the Tempest is a little bit more robust. I would choose Tempest fine wire, massives, and in the real world of what you're going to get at the end of the day, it's not going to make a huge difference. The fine wires are better, but are they so much better that you want to spend the extra money, one way or another? There is some performance improvement, I think, with the fine wire. And they definitely last longer. They'll last longer than the difference in cost.
Yeah, I use Tempest massives in my airplane, but the Tempest fine wires work out to be about the same cost per hour because they're 4 times as expensive and they last 4 times as long, roughly.
Yeah.
And theoretically, the fine wires do offer a little bit of advantage in smoothness when you're operating very lean of peak. Why is my phone?
Oh, that's Champion. Champion is calling. They are not happy with this discussion.
Sorry, guys. We have to edit that out. But anyway, there are some subtle advantages with the fine wires when you're operating at very lean mixtures. A little bit less cycle to cycle variation. Some people claim a slight increase in fuel economy is possible with the fine wire plugs. If I was getting fine wires, I would definitely get the Tempest plugs. As Paul was referring to when he was referring to the ceramic, he was talking about the nose core insulator, and there is a history of Champion fine wire plugs getting cracked nose core insulators. They're more fragile,
which can take out a cylinder.
Yeah.
Yeah, with
in if you're very unlucky, it could cause preignition. It doesn't happen very often, but the Tempest fine wire plugs are somewhat more robust, and so if I was going fine wire, I would definitely go with the Tempest plugs. I like the Tempest plugs better for a bunch of reasons. They nickel plate them so they don't corrode. The Champion plugs are painted, so if you scratch the paint, it gets.
I'd like to weigh in that I love fine wires. I've been running them in my Cardinal for quite a long time. I use Tempest. I still have massives in my Skybolts. I don't know why, because
You're
to me,
you're not in charge of those.
you have to keep gapping them, and they wear down. You have to replace them. I always have to keep a couple extra because every annual it's like maybe a spark plug needs to be replaced. The fine wires, you don't really have to gap. Don't normally have to clean them. They run real clean. I ended up taking out 6 massives out of the lower parts of the cylinders in my Lancer because it was fouling plugs a lot, and that was a long story. We had trouble with leaning the engine out. We had to change how the fuel was being delivered in the engine. So we finally fixed that. But to correct the fouling issue, I put fine wires in, and the fouling issue went away. So for idle operations, it was wonderful for the Lancer. I've always found, too, it seems like it runs smoother or even gives me more power on the fine wires, but maybe I'm making that up.
No, so what
That's
you
real.
said, kind of what I've been seeing. I've been about 30-ish hours now on the massives, and I agree with the idle. It definitely before was idle. The only really operational difference I've seen, and I run Lena Peak, is the on your JPI it says the differential, the EGT differential, or whatever. That's much higher than it was before.
On the massives.
On the massives compared to the fine.
Yeah, I looked at your data. We're looking at on the screen now. This is the Tempest. You can see in the upper plot, the EGTs are spread. I can't see the spread. It's 6.
Have you done a
13.
gaming lean test?
It's like 50 or 60 degrees EGT spread. And if you compare that to the fine wires, the spread is like 20.
So
20 degrees. It's much
I'm wondering
closer.
if was any other maintenance done when you went in and changed the spark plugs?
No, but depending on which set of data that you guys have up there, there was one thing I found out later after I sent the data to Ian, was that I have the Continental tune injectors, and when they took them out to inspect them, they mixed them around. Okay. So I figured that out shortly thereafter, and everybody got put back where they needed to be.
Right. Did it tighten it back up once you did that?
Not really.
Really?
EGT difference is still the same. Now in here somewhere it probably shows there were some EGT swaps where they wouldn't all move together, which is kind of, after I looked at that a little bit, I was like, oh, something isn't right here. So thanks to the wonderful tools that you guys have for us to look at data, which I really appreciate.
The part of this whole thing that bothered me the most is when you said the shop insisted on going. Shops aren't supposed to insist on that. That's not supposed to be their decision.
Well, but they might be saying they're unairworthy. They didn't pass the bomb test. Yeah.
No. But the shop insisted that he changed to
massives.
To massives.
Yeah, they shouldn't.
They insisted. Why? Because that's what they had in stock, or I mean, what?
Yeah, probably. Well, they didn't want to have to have the risk of one of their mechanics possibly bead blasting
them and then
the fine wires again.
Yeah.
Quick follow-on question, if you guys don't mind me asking, since Colleen brought up that she uses both. So I've heard tale of people putting half and half, like fine wires on the top or massives on the bottom, or vice versa. What are your thoughts on that? Is that
it would be
operational
fine wires on the bottom because
because
they're more fouling.
So you just rotate them forward in the firing order along the bottom of the engine as opposed to swapping top to bottom. But does
it make a difference in any way, or is it just the fouling?
It's just the fouling, and I was too cheap to do the whole set. That was the issue.
Yeah, I mean, the reason that I use Tempest Massives is very simple. I have 24 spark plugs.
Yeah. It's expensive. It's very
That would make
expensive.
my eyes roll
Is
faster.
I don't recall that we've had a caller with a grand piano in the background. I think that's very
Oh,
impressive.
yeah, well,
That's not real life.
Those of you who are listening to the podcast just in audio only are missing a lot.
he's actually in a closet, or he's in
Yeah,
in front of
right.
the bathroom mirror, so he doesn't want us to see.
I'm still waiting for someone
That's
to call
a
from their
holographic
airplane.
piano, right?
Yeah.
The holographic piano.
Well, Mike, you have a background too. Jeez.
But,
Yeah, Colleen and I are realists.
Yeah, this is what you get.
It's-
But yeah, half and half is fine.
Well, those are
Thank you.
holographic rabbits in the background with the.
All of it. When the massives go on the top, I'll probably put fine wires on the top too, because I do think the performance is better, and I'm looking for every inch I can get.
Well, I appreciate it. Thank you all so much. And Paul, I heard you that you just visited Lee Summit, Missouri. Hope you enjoyed our town. It was.
I did. Yeah, I definitely did. I spent a whole week there, and it snowed.
Oh, you were there that week.
I was there that week. That's
That
right.
That week.
That week.
Wow.
Yep. So, but it was a great week. I learned a lot. AEA has some phenomenal training, and I'm not
AEA as in the avionics guys?
Yep.
That
Yep.
AEA? Huh.
Yep. So they have it's a class on 145 repair station, basically writing the manuals and the procedures. I am writing my fourth repair station manual, but the last one I wrote was over 30 years ago, and things have changed a little bit. So I decided, I'm going to let someone else help me figure this out. So
You're not turning TAS into a repair station, are you? My God.
For doing the IFR research.
Oh, just a limited repair station. Okay, cool.
Yep.
That's worthwhile.
But the manual is still just as painful to write.
Yeah.
And you guys know how much I hate writing. Mike writes a 3,000 word article in
Every
like
month.
15 minutes. It takes me 30 days and I'm still late.
You can't even count to 3,000, right?
I can't count. So I make mine 1,500.
Can't you just buy a repair station manual for that?
It's not the way to do that, because you really want the repair station manual to reflect how you actually operate and not make yourself operate the way the manual's written. Sorry, Brian. Squirrel.
Yeah.
Very interesting.
Yeah. But anyway, Lee Summit was a wonderful place to visit for sure.
Very cool.
Glad you enjoyed it in the snow.
Yeah, in the snow.
Thanks again. I appreciate y'all taking my question.
Thanks for calling.
Thanks for the call, Brian.
So insist on Tempest fine wires.
Yeah.
There you go.
Don't let the shop insist.
Wilco. Thanks again. Have a good one.
Thanks, Brian.
Yeah.
Our next question is from Dennis, who is questioning the carb heat gospel. Go ahead, Dennis.
Well, as I told Ian, first of all, I'm really honored to have been chosen for this program. just as all your guests say, we consider you guys to be the ultimate resource in aircraft maintenance advice most of the time.
Most of the time. Good.
Did he tell you that there was this huge, big, long list of callers and you were some special chosen person?
Oh,
He tells
No, he
everybody
really-
that.
He lies to everybody.
He lies to everybody.
well, I'm lucky enough to have a 1964 Cessna 172 Echo with a 0300 Continental engine that the previous owner put in there in 2002. So got about 500 hours, a little over 500 hours on the engine. For myself, I do everything I can legally to the plane every week to keep it flying safely and to save as much as I can. Because I don't want to put a lot of money into it, but I do what I can legally. I hope the FAA is listening to that.
We got it. We got that. We've noted it as well.
But during COVID, I flew to almost all the airports in Virginia and went to a bunch of fast team lectures and visited several aviation museums and earned the Virginia Aviation Ambassador Award, which was a really nice leather jacket with my name embroidered on it.
Wow.
Wow. Congratulations. That's very cool.
I'm proud of that. And since then, I've been working on Maryland. A little further for me to fly since I'm in Southern Virginia, but puts a lot of hours on the plane, which is good for it and good for me
That
too.
is good.
Absolutely.
Well, my weekly objective is to make at least 3 landings every week. If I don't do anything else, if I don't do any cross country work, and one of those 3 landings is on grass. We have a grass field near my local airport. So my question really comes down to, is the carb heat really necessary on an approach all the way to landing? Because I do check it on downwind to see if the engine stumbles at all. It just seems like it's an extra step that you have to do to remove it if you do have to do a go around, because obviously it does rob the engine of power. So I was hoping you guys could give me some insight.
But everybody's waiting.
I mean, I don't
That's it.
fly a carbureted engine, but I think just checking it and then taking it back out is the wrong thing, because the carb ice happens when the engine's at low power, and it's at low power all the way down to touchdown. So I think when you want the engine, it's not going to be there if the carb ice comes in because you didn't have carb heat on. I think you need to, and your POH says you need to leave it on.
Well, I'll throw a couple of comments in. Colleen, that last thing you said, that's terrible. You're suggesting that that POH is something that we should follow. If we went by that, none of us would be flying Lena Peak, and let's not go there.
Okay, all right. I fly fuel injected engines.
A couple of comments. If you were flying a newer 172 that was powered by a Lycoming engine, the likelihood of developing carb ice on a Lycoming is very low, because the carburetor is bolted to the bottom of the oil sump and it runs hot, and you basically has carb heat all the time. With a Continental engine, like Euro 300, those are quite susceptible to carb ice. On the other hand, if you would like to not be using carb heat all the time the way the POH says, you might want to consider installing a carb temperature gauge, which I think on those engines should almost be a mandatory addition. And then you can see whether the temperature of the air going through the carburetor is in the potential icing range, and you can know whether carb heat is really necessary. And if it is, you can know how much carb heat is necessary. You don't always have to go to full carb heat to get out of the potential icing range. So, but if you're flying a Continental engine and a carbureted Continental engine, and you don't have any instrumentation, then it probably, in an abundance of caution, makes sense to use carb heat during approach and landing.
Yeah, I agree with Colleen. If you don't have the instrumentation, I would certainly leave carb heat on all the way down. And so I will make a comment, though, about Lycoming. In the Skyhawk, I would agree they don't make a lot of ice. I flew a single engine Comanche 250 for 13 years. And it's not the ice maker that like a 182 might be, but man, you talk about an ice machine. So I've been flying a lot of injected engines, and I'm on my way to East Tennessee. This has been 15, 16, I don't know, maybe 20 years ago. And I'm flying along IFR in and out of the clouds. And I look down and I realize, man, my speed is down about 10 knots. And I keep watching it gets down about 20 knots. And then it kind of comes back up. And it took me, I'm a little slow, on the uptake. So it finally dawned on me that every time I went into the clouds, my speed would drop down. And I'd come out of the clouds, it'd come back up.
Really?
And I'm thinking fuel injected engine like Colleen. I've got in my brain, I've been flying a lot of 210s, but I had this Comanche. And come to find out, it was carb ice. And when it finally dawned on me, I was down to about 90 knots on an airplane that typically is cruising at 150 to 155 knots. I'm at 90 knots, and this is how bad it is.
Wow.
I'm debating on whether to tell Helen that we're down to 90 knots, because she's sitting in the right seat reading or, whatever it was she was doing. And I'm thinking, I'm going to have to tell somebody sometime eventually. And then it hits me, it's carb ice. And like an idiot, I then yanked the carb heat out.
No, and you went,
All that ice
Everything.
breaks free.
Ice breaks free and all that. And I didn't have any realistically usable temperature gauge. But I think if you've got an airplane and you're on downwind to land and it's a carbureted engine, why not just go ahead and pull the carb heat? And when you go around, just make it, you use your whole hand to push everything forward at once. Mixture, throttle, everything. It's, that's not a huge extra step.
Well, that's what I used to do years ago, is to just push it all the way back in if I had to do a go around. Probably don't do a go around as often as I should, but we never do.
I think I would push the throttle in first to be sure that it's going to come up to power, and then bring the carb heat in. And that's just something that just now occurred to me. I haven't thought through it, but for some reason that seems like a hit the throttle first and then the carb heat, as opposed to the other way around.
I've never heard of anybody that had a carburetor temperature gauge, so I'll
really?
I will look into that.
Yeah, that's a very common thing to have.
They're not very expensive.
Is it hard to install? Do you have to modify the carb?
No, the carbs all have a port.
Yep.
For that, it's just a little plug that you remove, and you screw in,
and it goes to the panel.
There are two kinds of things you can screw in. You can screw in a carburetor ice detector, which is an optical probe, or you can screw in a carburetor temperature gauge. I personally think the temperature gauge is more useful because it
gives you
it lets you anticipate ice, whereas the ice detector only tells you when you actually have
an idiot
ice.
light.
Yes, exactly.
Okay.
I think there might even be an audible warning on them too that you can put into your audio panel.
Dennis, that sounds like a good Christmas present. Although,
Yeah.
just miss Christmas. How about a good,
Easter present?
Easter
But
present.
I think they're very inexpensive, and I think you can just buy one of aircraft spruce or something, and it's easy to put in.
Well, I'll definitely look into it. I think that's a real good idea.
Yep.
Cool.
Thank you.
Good question.
All right.
Thank you.
Yeah. Thanks for your kind words, and thanks for the good question, Dennis.
You're welcome.
Thank you,
guys have a
Dennis.
good day. Good
You
day.
too. Enjoy.
Okay, well, that's another episode in the can. Hopefully, we got a couple things right. We'll count on you to let us know what you think. Please send us your questions. They keep the podcast going. We always look forward to hearing from you. You can email us at podcasts@aopa.org.
Where you can pull this episode out of the can and listen to it again. See you, everybody.
Bye, everybody.